Let the currents flowing through the meshes be I1 and I2 respectively. For mesh I1, it is quite clear that I1 is essentially the current source. Hence, I1 is equals to 4. In mesh 2, the voltage source is flowing opposite of the current I2. Hence, minus 60, phase angle of 30 degrees, is equals to I2 minus I1 times the impedance of the inductor, which is J10, plus I2 times the impedance of the capacitor minus 5J. Since I1 is known, we can easily determine I2 as 10.58, the phase angle of 79.1 degrees. The next step is to determine the powers generated and absorbed by the elements 1 to 5. The expression for power is equals to half V times I times cosine theta, where cosine theta is the power factor. Let us start with the voltage source indicated as element 5. The power P5 will be equals to half times the voltage, which is 60. The current I2 is 10.58, and cosine angle will be 30 degrees of the source minus of the current, which is 79.1 degrees, and this works out to 207.8 watt. For the current source 1, V1, the voltage, is equals to 20 I1 plus the impedance of the inductor times I1 minus I2. This works out to, since we know I1 and I2, to 183.9 plus 20J, or 184.984, phase angle of 6.21 degrees. This allows us to work out the power as minus half times 184.984 times the current I1, which is 4, times the cosine of 6.21 degrees minus 0 degrees, and this works out to be minus 367.8 watts. For the resistor 2, V2 is equal to 20 times I1, and that will be equals to 80 volts. Hence, the power P2 will be equals to half times 80 times the current, which is 4, and that works out to be 160 watts. Powers are neither absorbed or generated in the inductor and capacitance. Hence, P3 is equals to 0 and P4 is equals to 0. It is important to note that P1 plus P2 plus P3 plus P4 plus P5 adds up to 0. This tells us that power is conserved.